Hey, good morning, good afternoon, good evening, whatever time it might be out there where you are. This is Manning Publications. My name is Jeff Fritz, and today we're going to talk a little bit about how we model language as tensors. And I've got two guests here joining me today. This is Chris Mattmann over here on my upper left, and over here is Dr. Scott Penberthy. Let me introduce them. They've been working on a couple of books, they've been working on a couple of blog posts all around the idea of TensorFlow and making reading and comprehending language a little bit easier. You're going to see a link pop up here in the chat every couple minutes that links to a Medium article called The Ultimate Speed Reader, talking about using TensorFlow and a tool called BERT. We're going to learn more about both of those in a few minutes. Let me introduce first Chris. Chris Mattmann is the Deputy Chief Technology and Innovation Officer at NASA's Jet Propulsion Lab, where he's been recognized as JPL's first principal scientist in the area of data science. Chris has applied TensorFlow to challenges he's faced at NASA, including building an implementation of Google's show and tell algorithm for image captioning using TensorFlow. He contributes to open source as a former director at the Apache Software Foundation and teaches graduate courses at USC in content detection and analysis and in search engines and information retrieval. Good to see you, Chris. Hello.
Thanks for having me on the program, Jeff.
And over here is Dr. Scott Penberthy. Now, he's a director of applied AI at Google. Dr. Scott helps train people on how tensors work, how they flow through computational graphs, and how to use powerful new cloud-based IDEs. Tensors are the heart of Google, enabling us to reason with images, video, text, and speech. What the industry calls unstructured data. Yes, I TensorFlow. Good to see you, Dr. Scott. How's it going?
Hey, morning or afternoon, Jeff. Good to see you too.
Oh man, when I read through and I was learning more about BERT and TensorFlow, and I was really getting into this, the article hits a problem, hits a thing that I think a bunch of us have here, right? And it's talking about, the article talks about speed reading, analyzing data, and in a time of COVID, in a time when so many folks are, and I'm going to share a link to that article in chat, so many folks have so much data being thrown at them, right? And I look at my phone right now and gosh, I've got 48,000 unread messages. Let's get into this simple and start simple. What are tensors, and how do we use them to analyze text?
Well, maybe I'll take a stab at that one, Jeff. I think tensors actually came from at the dawn of time. It seems like the dawn of time, around the time of Einstein. He wanted to figure out how do you represent time and space in the same sort of calculus, and he used something called Tensor Calculus. Like what is that? And what it boils down to, if you take away some of the physics implementation of it, it's sort of just a multidimensional vector. And I'll give an example. So a 0D tensor is like a cell on an Excel spreadsheet. 1D is sort of a column. A 2D is a sheet. A 3D are a bunch of sheets. 4D, a bunch of computers. And so you can just take these ad nauseum, and what happened is it's a well-formed multidimensional vector in the sense that all the rows and columns go all the way to the edge, and it's like these cubes in very high space. And a lot of tensors we'll talk about, they have some interesting properties. One, you'll see that a lot of these algorithms we use, the values in those cells, they tend to be between -1 and 1 because these graphs are very, very sensitive, extremely sensitive to the way they work. And what you end up doing is, a tensor is a way to encode all kinds of things that we see. We can get into more details. Anything else that you might want to add on that in terms of tensors flowing through graphs, Chris?
Yeah, my big thing, is that it really started to make sense to me when I thought of it as sort of an activation map. So, we do a lot in climate science with masking out information, just work with a lot of climate people at JPL. And what a mask is just a sheet that information passes through. And like, Scott was saying about tensors, it's that just imagine them as different dimensional sheets that have some sort of filter on it. And we're really concerned about that, when we talk about information in areas, say geographically, that matter to us. You can think of a tensor as just that sheet that information passes through, just some mask that sort of identifies and represents that information and how you manipulate it. But I don't have anything else to add. You nailed it, buddy.
Yeah. So yeah, I think what's interesting here, Jeff, is that tensors to me. I mean, my license plates are Tensor 1, Tensor 2. So, I mean, I'm a big fan. I think that to me, it's a new style of representing features and data structures in computing. The number of people who know this, there's 10,000 who think about this every day, and the programmers at TensorFlow and PyTorch, they don't give it second thought. The rest of us probably never heard of it before. And I think it's like as common in AI as a relation is in the database world, and or like a JSON structure is in something else. And so I think as more and more learn about tensors, like we use them at Google for representing language, for representing speech, for representing us, for URLs. It's a very compact way to represent a lot of information and reason about it.
Oh, very cool. Okay. All right. So now, so tensor is that base unit of storage and manipulation for machine data that we're talking about. Now, in the article, it talks about the tool BERT, right? And there's comically a picture of the Sesame Street character BERT. What does BERT do when it gets these tensors?
Yeah, so we have 2 hours for this? Is that what we're going to talk about?
Well,
I don't know. I'll take a whack at it, Chris. I don't know. I mean, it's BERT. I keep thinking that they probably just like Sesame Street characters and had to reverse engineer the name. That's what we all do, right? I want to name my program this, and the name I think stands for bidirectional encoding representations using transformers. Where it comes from. And
well done.
What's neat about BERT, and we can get more detail if you'd like, is that you can represent words as a tensor.
Okay.
We can get to how you do that. And what's neat about BERT is you can also represent paragraphs as tensors. And what the way that all these algorithms work is that you take a tensor, and you mentioned it, Chris, right? You take a tensor and you flow it through what do you call a sensor? You call it a map, right? An activation map. What happens is as you flow tensors through a graph, you can change them a little bit. And a lot of the AI systems are tensor in, tensor out. That's how it works. And what BERT is that it's sort of an ingenious idea. They said, what if we built an AI and fed it the internet? And like all of it. So I guess you think that way, Google, I guess. And so what they did is they said, here's how the setup. We're gonna take a chunk of text, a paragraph, and we're gonna code that as a tensor, and that's your input. What we're gonna do is we're gonna play Mad Libs. We'll take a chunk of text, and we're gonna block out 5 words, let's say, and then we're gonna flow it through a graph, and the graph has got to guess what 5 words are missing. And you can imagine if you have Wikipedia and you chunk it into paragraphs, you've got a very, very large set of paragraphs, and you can just pick out 5 words. And you can be a little smarter about it and pick out words that are meaningful, not just the and, but pick out words that are less common. And if you train an AI, which BERT did, at the time it was the best in class. And something just trumped it, I think, last week. I think it's called Marge. But BERT, the idea is that if you train an AI, what ends up happening is the AI, it starts to figure out how the words mean in the context of the paragraph. Because so what's happening is you're feeding BERT a paragraph in, and it's got to guess 5 words. After a few million of these, it starts to get the hang of it and know in these blanks, these are the kind of words I want to see appear. And those representations of those words have a lot of contextual meaning that is more like, for example, the word bank. Bank, for some of you thought, oh, that's where I put my cash. If for those sports car fans, they said, no, I'm thinking about banking around a corner. If you're a canoe fan, you're like, no, I meant riverbank where I put my canoe. And you're all right. And the point is the word bank has context. And this is one of the first breakthroughs where the computer can now represent a tensor that has that context. And that came from sort of 2018 it came from a team of Googlers. And now it's sort of an interesting technique that sort of has taken the world by storm. And using that stuff in representing language is now, there's all kinds of derivatives, and they're all trying to one-up each other. But what's interesting about it is that we now have a representation for language that's starting to mimic how we think about words. I don't know. What do you think, Chris?
Yeah. So, I mean, for me, it feels like every couple years, like Scott was saying, like there's one of these sort of transformative, applications of machine learning, and especially, deep neural networks, and especially using frameworks like TensorFlow and so forth, with lots of smart people in Silicon Valley. And the early attention, I think, was paid, say, in the mid 2010s to, images, video, and things like that, because I think those were at least the place that were kind of at the tipping point where they felt like we could move the needle ever so slightly, and it was right there. And it feels like over the last 5 years, they've turned around on some of those approaches, and not just use them for things like prediction, and things like that, but to come up with representation and to apply it to things like text. So I mean, I come from a lot of statistics background, and so forth, where it's like you see across all the domains, people are saying, oh God, what are these black boxes? What are these neural networks doing next, to kind of invalidate all my statistical assumptions. And it keeps getting kind of turned on, the latest, people in the blog sphere and Twitter that were, killing each other or getting pissed off were, say the people dealing with machine translation, because all of the approaches to that, from translating from one language to another, which is a big text, sort of problem related to deep learning. All of the approaches for that were really based on language. They were based on knowing a lot of statistics about word properties and things like that weren't put together in sort of a way that was like we think, like Scott's talking about, biologically inspired. And the beauty of all of these, techniques, the things like BERT, are that all we do is we look at biology. We look at the way, just like with computer vision, and we look at the way the brain activates, when we see certain images, what types of labels that, fires off in our mind and things like that. This is the same concept kind of applied to text. It's like Scott said, it's, putting together patterns in our mind of Mad Libs of words and sentences that we want to complete, and then trying to fill them in with what fires or what activates when we see things. And if you feed it the knowledge of the history of the world, which, you or I, or, Jeff, Scott, I don't know how much time we have, like Scott said, but that would take us quite a while. It doesn't take the computer quite a while. You get those feature representations after that, and you can play ball, so that's, I'm tracking. So.
And it's interesting because I think some of us have seen there's some very well documented and shown sentiment analysis demos where, right, people run sentiment analysis against Twitter, and you could see when people are getting angry as something's happening, or, right, the Super Bowl, you can see, right, here in the States, right, American football championship game, and all the people in New England are happy that the Patriots are winning, and people in the rest of the country are not, because nobody likes New England. But, right, I feel like sentiment analysis.
Brady's in Florida now, there, so.
Yeah.
Well, we'll see what happens. But I feel like sentiment analysis was, from hearing you, Chris, I feel like sentiment analysis was almost like a gateway drug, where, right, we got that initial concept of the machine knows what some of these words mean, the feelings and the emotion when they're being pulled together there. Are you telling us that BERT knows even more than just sentiment of things and can relate things together?
Absolutely. That's one of sort of the natural kind of enclaves that BERT fills a gap in. And I know quite a bit about sentiment analysis or whatever, and the earlier models basically to do things like that all relied on this sort of concept called bag of words, which is coming up with a representation that sort of made sense to us. I think if you were looking at text, it's a big histogram of word counts and things like that. So words that occur more frequently, this is back 10 years ago, so it's naturally ancient. But, the old approaches for that were words that occurred more frequently in that histogram were more important towards the eventual label that you got for sentiment, whether it's positive, negative, or whether you slice that spectrum up into like, love, angry, mad, sad, like social media companies do. So you take a bunch of those features like you normally do in machine learning, which in those cases were counts from histograms, and then you try and see which counts or which most frequently occurring words imply that sentiment. That was sort of the naive approach. Wasn't biologically inspired, but it had that kind of concept about activations and things being more important. Here in BERT, it takes it to the next level. It's not just looking at word counts, which are sort of, I would say, shallow features. It's actually, taking a look at representation, relationship between words, co-occurrence, where they occur, sort of locality, And Scott, I don't want to embarrass him, the father of Bert, here, but I mean, it's like bag of words on steroids.
Yeah, well said, Chris. I think bag of words is one way where you have human engineered features, right? And what we're finding now is that you can sort of stretch that idea and saying instead of a histogram of a few counts, you have sort of a very in Bert's case 768 values in the small case, right? So imagine representing a concept of 768 numbers, and in there is not only sentiment but things like the sense of meaning. And if you can imagine a very high dimensional space, what's neat about it is that those 768 values are just a point in space, right? Much like how you might, if you look at the brain, if I mention different political figures, turns out it activates the same part of your brain. And so what that means is there's different points in space are kind of close together. And so what's neat about BERT is that you can actually train BERT and continue to train it further, where such that you start to have these properties where points that are close mean the same thing. And that is sort of fascinating. So not only is sentiment in there, a lot more value is as well. And what's nice about this is that instead of having humans generate the features, which are still very powerful, word frequencies, statistics, that sort of thing, BERT gives you a very high dimensional, very fine-grained tool to represent what the essence of the word, and then you can use traditional techniques to analyze those things. So basically looking at where do the points cluster. It's good old-fashioned machine learning. Or how often does this point occur? Things like it in this space. It's just a new machine-generated tensor as a new type of feature for how you represent words. It's super powerful.
Oh my gosh. Yes, definitely sounds right. It sounds powerful because now we're getting beyond just positive, negative, and into meaning. And Scott, if I hear you right, it sounds like, we would be able to unleash BERT on a series of documents around the Civil War and generate almost Cliff's Notes of here's what happened during the Civil War and the writings, according to the writings that we have around that topic, right? Feed in the Gettysburg Address and all these other documents that from that time and learn more about that, a deeper learning about it. That's so fascinating. Now, but I mean, things that are practical for us today, right? The article talks about COVID-19, so many folks writing documents, papers around this, and we need to boil these down. We need to figure out, right, as people that are trying to learn and figure out what to do about battling this. How can BERT help us with that?
You want to try Chris first, and then I'll follow you?
Yeah, if there was ever a time, I would say that, we need to quote speed read or whatever, it's during a kind of global pandemic. And Scott and I have been part of teams, working together where this was important even before then. It's timely. There needs to be some type of tactical intelligence in finance or health or climate or things like that. But God, today with a pandemic, we need to do speed reading, and what we're talking about there is sort of all sorts of things, relationships, say, between drugs, relationships between treatments. How do we find that next remdesivir or something like that? And so what happened probably, I think, God, I don't know if we're week 18 now, when we went remote and things like that, but in the early stages of the pandemic in mid-March, a bunch of smart people got together and the government put out sort of a call to have this sort of competition, and it was associated with the machine learning company Kaggle. The Bill and Melinda Gates Foundation got involved. Google got involved. All the big Silicon Valley companies. Some of our team at NASA got involved, and basically what they were trying to do is they said, hey, look, take these smart AIs, things like BERT, out there, and see what the system can glean, from that. And they were interested in some questions. How does the disease transmit? How can we treat the disease? What have other things that have been successfully used in SARS and related sort of coronavirus, types of things? And so these are all things that normally, from a formulation perspective, if we were going to do this by hand, and I've been part of teams, at JPL that have done this. I'm sure Scott has been as well. You get people together, you start reading papers, you start doing research, you do hypothesis generation. Let BERT do that for you. And that's basically what's been happening the past few months. is that teams around the world have been using techniques like BERT to kind of not just quickly summarize the articles and figure out how to generate more of it, but it's how to generate knowledge, how to come up with questions. Even you can use BERT to relate similar questions that were inferred about, so not just transmissibility, but locality. Where is it being transmitted? Oh, not just drugs and disease, but how does it relate to locality and things like that? And so BERT, as a representation and using places like Google and their ability to have all the data in the world and to run these techniques where it doesn't take the age of the universe to run is a very powerful thing. And that's basically what people have been doing and making a lot of progress.
Yeah, I agree with Chris. I think, what we're seeing is, you talk to a number of governments, and so imagine if you're trying to figure out the right public policy, and you want to sort of get that feedback from social feeds and whatnot, but figuring out, how are people feeling about this? You need to have, someone like, can someone please listen to all the TV stations, all the radio stations, all the local news, and tell me what's interesting, and where might I start looking to figure out, how's my policy being implemented across a particular state. And that is something that's just prime for BERT, in the sense that what you can do is by taking the problem and scaling with machines, like say in a cloud like Google's cloud, you can then actually do this all in parallel. And what's nice about that is now you have all these computations in parallel, and you can do things like take your question, which is also BERT can turn into a tensor, and then take the articles, which BERT can turn into tensors, and then it's a matter of math. In other words, if your question is a point or set of points, what other points are close to it? And then if you look at the points in this space, how are they clustering together? What that tells you is, what are people talking about? And we've applied this, and what's interesting is you look at the set of questions, the set of points, you're like, what are these? I don't see how they're clustering. Then you realize, oh, it's about local politics and the impact of stay at home. You look at another cluster, like, this is also confusing. Why do they have these people? And realize, oh, this is about celebrities and celebrity impact, because they use similar language. And so it's fascinating how BERT can find these clusters that initially seem counterintuitive, but as you dive into them, like, this is pretty interesting, because it's finding that the way that we talk about things start to cluster up. And so those are some early techniques. And what we're finding is, not only is it powerful, it's a great complement to what Chris talked about before. So we're not sort of throwing out the old technique. It's sort of an addendum that makes the old techniques even more powerful.
Yeah, and we're not replacing people either. Like Scott's talking about. I think one of the scary parts about this, every time I hear about this, I talk to people about AI or machine learning. Scott does it a lot too. One of the concerns too is, wow, just another thing that's going to replace my job and things like that. But really what we're doing is we're shifting, I think, what's important to do as part of jobs, and things like that. So many people spend so much time doing very basic things. I myself do it. Whereas if I could shift the types of things that I'm doing, is not just looking and trying to, stay up late at night, read words and see which one's fired in my brain. Let something like BERT do that for you, and then pick, which of those, say, activations, or pick which of those things, give limited amounts of feedback sort of after that. You shift my job, you make me more efficient, and, you're not taking me away from my kids and, my wife at night, and, we don't want to do that. That's bad, So Scott's shaking his head.
Chris,
so.
I love that example, Chris. There's a company out of England called Ocado. For those in England, you know it well. Outside England, it's sort of a robotic grocery store. It's fascinating, and talk about perfect for what's happening now, right? So, but here's an issue there. So you've got all these inbound questions, and here's two questions in the inbox. One is, where's my milk? And then the second one is, hey, I saw your van. How do I sign up? And so if you're thinking about a business goal of, I need to go ahead and drive better customer sat, which question do you answer first? And it turns out you should answer the milk question, because if you wait too long, the milk expires. And so by answering the milk question, for the same amount of effort, you can drive a better customer sat and have a better outcome. And so those are using techniques like BERT, where basically by looking at the inbox of something like Ocado, can you figure out, what do I answer first? So the time I do have in my job, how can it be most effective? And that's what we talk about in the blog post, is that, Chris and I both probably have inbox fatigue. And you mentioned 14,000. We separated some in Gmail and whatnot, but still there's all these other stuff you want to get to. And these are the kind of techniques we're starting to see, where it can help you and learn from you, saying what's important to you. And then what you also do, as you think what's important to you, for ethics and fairness, what you also want to do is take random samples as well. So the idea is you have the algorithm, but it also throws in some random ones because it may learn over time how your interest shifts. And so that's sort of a neat blend of how you go through these big inboxes.
Now, that's really interesting to me, right? Scott, how you brought that back to Gmail, right? Because I'm a longtime Gmail user, right? And when I look at my Gmail box, I don't look below the important section, right? I know,
Right.
and I've now developed a trust in Gmail that those things that are marked as important are bubbled up to the top, and you're telling me that there's a little bit of artificial intelligence that's going in there to bubble those things up because it knows the things that I find important.
Absolutely. And a lot of that, and I think these techniques I talk about, they're endemic to a lot of the products now. And it's all about how you're making the products more useful. And if you think of Gmail, I think, as it's learning from you in terms of what you click on, what you're reading, that's a signal. And then BERT, encoding things with things like BERT, it can start to do the math and say, these things seem to be interesting to you. And, one adage we have here at Google is not only do the important, but every now and then just take a random walk. Look at the things that are not important because your interests may have changed. And so that what you can do by picking things out, you're signaling to the algorithms and the AI behind Gmail, this is also interesting. And so it's like, how do you sort of work with these systems so they continue to serve you better? And I think that's what you talked about, Chris, right? Is how do you, it's in the sense of, one, making your job a lot more fun. You can focus on the things that are really having value, and the value you can provide as a human is really starting to ramp up.
Yeah, one of the big things that we do, in my team at JPL is what we call Formulation Studies. JPL has a sort of concept shop end to end to think about, say, missions that are 50 years out, NASA missions that may be entirely autonomous or may include some special instrument that it doesn't include today. And so part of that we have is the team called the A team. And what they do is they bring people together, do subject matter expert research. They have like a couple-day session, brainstorm, and they output a set of designs which may or may not kind of get picked up and brought forward to like a real cost model and something that would get on slate to potentially be funded and like a decadal type of mission. A lot of times during that process, it's all business intelligence and research applied to science. And the way that people kind of source those types of things over the last, say, 5 to 10 years has sort of been endemically changing. With these types of technologies like BERT, is like now today we don't have to spend a week doing, say, consumer research or can we build this instrument? Who else is building it? Competitive research. Who should we be collaborating with? What types of scientists are doing this already at what institutions? Let BERT read that for you. And instead, let's take those questions, let's take those, sets of research websites, papers that we get after that, don't read them. Let BERT read them for you as well. Take the outputs of that, and notice that this could be sort of applied iteratively, and it is, and that's the way that it's going on today. And again, it's shifting. What it's allowed us to do is to go from, say, big sets of teams where we used intern power and intern brains to kind of push this information forward to really taking SMEs and using that little subject matter experts, that little bit of time that you can squeeze out of them over those past couple of days, and changing the types of things that they dot an I with or cross a T on and things like that, and making the most use out of that. And so for us, it just directly helps my job and our teams every day.
Oh, very cool. And when I think about some of those things, and having been one of those people who was intern power at a financial company, right? Hey, we need you to analyze these spreadsheets and come back to us afterwards. And right, I was one of those people. I was a programmer. So I got into, well, gosh, I'm not going to just analyze this. I'm going to write a macro or two to sum and do all the things and take that next step learning. It feels like we're right at the beginning of being able to unleash tools, right, and machine learning algorithms like BERT, and just let it go, figure out, calculate some of these things so that, like you were saying, humans can focus on those deeper things, those new innovations. Let it do the analysis, right? The analysis, the summarizing of all that data that's a book report, right? Am I oversimplifying here a little bit?
No, I think you get it. I think that's what's so fascinating. And we call, I mean, in the research community, they call it extreme summarization, like extreme gaming, maybe. And, for example, I think it's in England, I think it is, where they've got, if you're submitting a technical paper, you have to write one sentence that summarizes what that gist of your paper is. And it turns out you can take all those and use a BERT model and then start train BERT saying, hey, when you read this paper, first read the paper. And what happens is we're flowing the paper through a particular type of graph, LSTM and whatnot, with even more, which is like these transformers. It's a particular graph. Once you flow the paper through, you can have these tensor values. Okay, from those tensor values, here's a sentence I want you to generate. And you do it a few thousand times, it's getting better at saying that I just read the paper and here's the sentence that matters. So, I think that's sort of cutting edge research, doing things like that, of taking a paragraph and saying, can you get the topic sentence out? Or can you generate the title? And this is like cutting edge research. We're getting there where now, instead of having to go through 100 pages, we get 100 sentences over lunch. And what's interesting about that is they can help you focus. So now, imagining having an army of assistants in your job or in your task to say, what do I pay attention to first? And then also, just like you do with Gmail and whatnot, I'll just grab a few papers of random that just catch your eye to help make the algorithm even better. It's like having an army of assistants. And how do you train them to help you through your task?
Yeah, it's almost like having a Sesame Street of assistants, if you will.
Exactly.
I see what you did there. Way to go.
My attempt at humor.
Yeah.
So, and thinking further about this, right? And we talk about the large email box issue, right? And
Sure.
Gmail does good things to help us through that. Now, guys, you have me thinking about when we have a lot of traffic in a chat room, like on Twitch, right? There's things that are happening and coming through here. I have a little bot that runs on my stream that just does the sentiment analysis as messages come through chat. And it just reports back, hey, the chat room is positive, the chat room is negative. But now you've got me thinking, hey, maybe there's times when chat is very active that we could unleash BERT against those chat messages as they're coming through and get higher level topics that, hey, you know what? The chat room is really interested in this. Maybe here's a topic change we want to consider, or maybe for next time. Can BERT run that type of real-time analysis, or is there a bit of churn that needs to be going on here to analyze a good-sized collection of data quickly?
Depends on how much power you got running this Skype session or this Twitch session, on that laptop. Well, I mean, actually, the algorithm itself is absolutely real time. Tensors themselves, lazy executed graph. That's the beauty about this. Probably the last decade, the notion of sort of, I would say, secondary, tertiary storage and graph execution. Of computation, and sort of, what Tensors sort of brought to the fray too is the knowledge of that graph and how it gets executed, whether it's on a GPU, a TPU, a CPU, what types of things should be deployed where, and then what's the model of that execution and how it gets deployed. So BERT itself, sitting on top of Tensors, sitting on top of say a framework like Google runs or TensorFlow or things like PyTorch from other places, super fast, can be applied. Invert the problem a little bit though. Rather than even topics, I'd say BERT could help you even do other things. For instance, take those questions from Twitch, group similar questions together. Everybody that's saying, hey, can Chris spike his hair any more on that, or can Scott can I get more pictures of Scott's Earth in the background, and things like that. You could group those types of things together, those types of questions, which would help you say, Jeff, in the way that you're answering it or prioritizing. Another thing you could do, and you might have seen this on things like Gmail, is remember, BERT is a Mad Lib answerer, right, for relationships between it. One thing you might see on Gmail is as you start to type a message, you start to get suggestions nowadays in some places for how you should finish that message. Well, think of how and that's basically empowered by BERT. Think of how you could apply similar things in a Twitch stream. I'm not saying auto answer people, but maybe give you a suggestion as to how to complete the answers to your questions and things like that. There's a lot of what they call in the domain intelligent digital assistants that are directly enabled by this. What do you think, Scott?
I love that, Chris. I think many years ago people used to wait in line to use a telephone. right? You get off an airplane, you wait, and that just seems crazy now, right? Wait in line for a telephone. So I think in the next decade, it'll be crazy to say you used to have to wait for a company to answer your phone call. Like what? Because you'll be able to chat and get an instant response. Like how does it know and able to talk to you? And I think that expectation is now coming in the 20s and the people who are very big Twitch fans, because they're coming up and they're going to expect that your business, you can reply, and with these BERT techniques, you can now start to do things about start to encoding what you find interesting. And so in order to reach someone, I think we're entering into an era where, like, if I want to meet with Chris, he's like, sure, how about right now? And Chris is like, what do you mean? It's, just talk to my bot. And if it really needs my personal attention, I'm doing 10 meetings like that right now. It'll pull me in where I need to focus. But if it's a common question that I know how to answer, my bot, which will look like Chris, can answer. And that technology is here today. And BERT, I think, is a language part of this, and we can talk about in the future how other pieces go. But I think this notion of, imagine that, for Twitch, being able to respond to everybody, given an answer that's consistent, and we're not be able to summarize and saying for you 15 people and then do a blast back. And that's the sort of tool that this is now soon enabling us to use. And that we're just getting started. I mean, the research in terms of how to summarize, I mean, it's 2 weeks old, right? And something that just came on top of BERT, and it was the idea of, instead of playing Mad Libs, let's do this. Let's take a paragraph and see if you can guess the next sentence, right? So can you do copywriting? So instead of like guessing words, can you do copywriting? It's called Madge, right? And so we're saying all these neat techniques where tensors are the new thing to represent language.
Okay, now that's really got my mind racing now, right? Because I love the idea of, my gosh, since I started getting suggested messages in Gmail, oh, it looks like you're trying to reply, yeah, I'll get back to you tomorrow, or let's schedule a meeting later in the week, and it knows those messages that I'm going to reply to some of these things. Now thinking about some of the common questions that you do get, but right, if we were hosting this show on a weekly basis, there's going to be common questions that we get. Hey, how do I get started with TensorFlow? What's a Jupyter notebook? Where can I learn more about Python? Right? And
there you go.
Yeah, and to be able to suggest those feels perfect for this.
Right. So Jeff, in the sense that your community could be talking to you right now and you're answering them, why are you talking to us?
Yeah.
And if it's more complex saying, I don't know, let me get back to you. And what that is then you get a ping saying there's 75 people that have the following question. You type the question, then it gets paraphrased and sent back to them. Why are you talking to us? And I think that's the sort of world that we're entering, where a lot of the tedium, but it's also important for maintaining relationships, you'll be much more accessible, right? So now you can actually use these tools to divide your time up, and things that you consider simple for other people are very complicated, Jeff. But if you could train these tools like BERT in terms of, when you hear this sentence, here's how I respond by just watching you. To BERT, it's just this tensor, I respond with this tensor for Jeff. That's all it's doing.
Okay, that's pretty cool. And now, right, these are things I experimented with doing a little bit of. Right, there's a Q&A feature on Microsoft Azure that I was trying. Experimented with that, and it never seems to get the answers quite right. Loading up an FAQ and trying to get these lined up, and it felt like it was just doing simple string comparisons. But where that Q&A analysis sounds like is not as advanced, it doesn't have the same type of organic, I believe, Chris, was the term you were using, the organic analysis that BERT will do around questions to be able to allow that rich interaction. Now, I mean, okay, we're talking about COVID-19 things. Have folks tried feeding in other historical data sets to do some analysis, a documentation of things? I always hear people say, oh, let's feed the JFK documents into a computer and see what it tells us. Is that type of thing something that really could be done here?
Well, there was a fourth person on the grassy knoll, but I don't have time to get into that. But besides my wacko conspiracy theories, that the thing I'd say there is, Scott kind of hinted at it earlier. It's all the things. You feed it all the things. And if you have a place where you can feed it all the things, these algorithms, not just sort of implemented using things like TensorFlow, but these networks and so forth, they get smarter with all the things. Whether you're training a speech model to do automated speech recognition, where I feed it a bunch of sound, and I might give it at 800 sound files. The outputs of say your intelligent digital assistant for trying to listen to what you're saying are kind of gobbledygook that sort of kind of get the articles right, like the and a, but then at 1200 files, it starts to actually get closer to the phonetic sounding. At 5000 files, those, speech to text are getting a lot better. And at, hundreds of thousands to millions of files at the scale of a Google or, an Azure or Microsoft, the internet properties can do, and how efficiently they can do, that's where the models are really robust. And BERT's no different. Whether you're doing, the way I like to say it, my big sort of epiphany over the last a couple years with machine learning is, oh my God, they're recreating our biological sensory systems, and now on top of that, they're accessing the part of the brain which sort of runs on top of it. So we got the wheels, we got the frame, and now we got the air conditioning, inside of the car, and so that's what BERT is. We can hear. Now we've got models of that. We can see with our eyes, and now we can activate other parts of our brains based on what we hear and see or read. And it's data hungry. They get better with data. And so the answers usually to that, when I tell people when you're building these models or when you're using it, is if the answers don't make sense, a lot of times feed that puppy more data. What do you think, Scott?
I think you're right on the money. I mean, it's the old adage in AI is that 80% of AI is cleaning data and getting it and feeding it for these, and the other 20% is complaining about cleaning data. And I think, but you're finding this now, but I think you're right, because what's interesting about tensors in general is a new representation in computing. And, in a decade, everyone's going to be using them. And it'll be like second nature, as easy as spreadsheets, really will be. And what's nice about what you said, Chris, is that you're right. If you call it the very much like a NASA analogy of that you got the frame, the wheels, the air conditioning. What's interesting now is that you're encoding multiple different sensory inputs as all the same tensor. And now you can start to transfer one to the next. And so you talk about, Chris, where you can now take pictures and generate text. You can do text to generate speech, because to the computer, it's tensor in, tensor out. And half of our brain is dedicated to the neocortex, vision and language, which separates us from the rest of the animals. And to me, that's why we're focusing here particularly on text, because we all have this problem. It's information overload. We've got lots of PDFs. We'd like to be able to read it all. We can't. So for the time I can read, can you help me? And can you help me find what's interesting and summarize that I can't? And then I'll test you. Like anything, you trust but verify. And then what that does, it helps the algorithm get better for use.
So, I mean, okay, we've talked about here's what it can do. Here's, the types of things. So I know that there's another article. We've got a couple more articles in the series that are going to happen here talking about the tools. To really get a little bit hands-on with it without actually writing code, opening up somebody's screen here and taking a look. We're going to run BERT. We're going to do analysis against a set of data, 40,000, 70,000 documents, Jeff's email box, whatever. And it builds a model after a certain amount of time that it does analysis. And that analysis time, right, varies based on how much computing power you throw at it. In my case, it'll take a couple weeks because I don't have a lot of computing power here. I don't have a Google Compute Cloud like Scott does. And when it comes back, it's just a RESTful endpoint. Is it the dumb command prompt, and I can just start what at that point?
That's what you want. I think Chris and I are putting one together right now where we show you, and it's, I don't know, Chris, 2 or 3 lines of code where you can actually use what's called a pre-trained model. And this seems to be very common, where the cloud providers, we're one of them, Google Cloud, will run BERT across millions of sentences, and we create these models that basically it's preloaded. So it's got the weights, it's got the graph kind of ready to rock and roll, has some representation for language. And what you can do is use that as a starting place. And then with very few samples, it can take the knowledge it learned from Wikipedia and transfer it to your domain. And that seems to be the money, where you take these big models that are baked in clouds, and then you can use those as a starting point for your models. And we show an example of this where we feed, the greatest story ever told to BERT in just a few lines of code, and you're able to find passages through this greatest story instantaneously as just an example of how fast this tensor stuff works and how fast BERT can learn, 66 chapters, for example.
Yeah, the sort of holy grail nowadays seems to be to do exactly what Scott just said. It's like to do transfer learning. He said it, transfer. So transfer learning leverages all of the investment, that companies like Google or Microsoft do in analyzing like all the data all the time, every day. And because it's okay, Jeff, that you don't have a computer that can do it. I mean, I've got some pretty powerful computing here, and even somewhat powerful at NASA, but I mean, I don't have Google's power, and so who cares? Let's leverage that. Let's transfer the knowledge on that. And again, it's all about what job you're doing. Do I need to go recreate the BERT for the internet? No, it's been done already. And so 20 years ago, the hot job wasn't data scientist or AI engineer like it was today. It was software architect. And I remember I supposedly studied this a long time ago. I remember one of the things they taught us is, the goal of being a software architect is figuring out how to copy and build off of everyone else and what they did, and to put those building blocks together. And that's really all we're doing here, is that we're shifting the focus, not rebuilding components that are already built. Now you build the thing that puts those things together. And that's really what we want to do. So that's what using a trained model already is. You take advantage of all those hours, all those CPUs, all those GPUs, TPUs, the compute, get those weights, which are really, the tuning parameters of the model, the knowledge, of the model, get that tensor graph, which is the current state of the model, which frameworks like TensorFlow allow you to do, and so forth, and then use it to basically predict things, to classify things, or to represent things, like here in the case of BERT, and then adapt as sort of necessary.
Yeah, I think what Chris and I are working on is two examples of that. One where you can take a model locally, and you can use it, in your own little, your PC, and just actually go play with it directly there. Or another model where you mentioned it earlier, Jeff, is it's a RESTful endpoint where you've got the power of the cloud, but it looks like just another single line of code, and that's where we're headed. And it depends on what you need. What's nice about these new programming platforms is that if you do it right, you don't know if it's local or if it's on the cloud. It's just that it's there, available, and then as Chris said, you build from the work of others, and that seems to be definitely the path forward.
Oh yeah, you guys have me thinking, Scott, particularly with that last couple of statements there, that the machine learning models are becoming like relational database was for us in the mid 80s. It was just an endpoint, right? Client server technology hit, and you didn't care. You were writing Power Builder, you were writing Visual Basic, Delphi, and you just had some sort of API and go do that thing. The database administrator took care of it, grooming it, making sure that the database was nice and well fed. And I feel like if I follow you guys, that's where our machine learning models are going to be. We've already got the power of Google that already knows everything that's on the internet. That's how they can search it so quickly. And let's bring that data together and hand it off. It'll let you qualify your domain, so that we can be black box with that, right? I don't care what's going on behind it. I know my business logic.
Yeah, we don't need to show you necessarily the hamster wheels that are inside of those boxes, and maybe this is what Scott was just going to say, but all of that great 80% data cleaning and 20% complaining about it, you don't need to see that. We just need to replicate that box 1,000 times for you, hidden behind an endpoint.
Yeah, and I think Chris, you're also seeing this. I think the next decade, you're seeing where relational databases. I guess what was it, the 80s, maybe a long time ago. Yeah, it was a new technology, and I can imagine back then people were saying, "Oh, let's talk about query optimizers. How about a query language? Oh no, B trees, D trees. How about data striping? Like what?" And they say, "Oh no, it's a database." Oh, I get it. Right. And so you don't know necessarily, most people may not understand how you store SQL, how that gets programmed, but you got SQL in a database. And most programmers now, that's just second nature. I think we're going to see that with tensors, where you start to have these tensor stores, and people will use tensors. It won't replace databases, it won't replace what we had before, but if you have data and not using a tensor, will be irresponsible in a decade, because it's going to be so easy and a tool for all of us to use. I think the vendors are now trying to figure that out. Well, what is a tensor? How does this work? How do we get these in the hands of everybody? Because it's super powerful, but it's a tool that adds to everything else we have.
Oh, yeah. And in the chat room, Jason says, can't wait for a data preparation for machine learning book from Manning. Chris is touching on this subject in his book. touching on that data preparation comes back to a little bit of, hey, maybe that's where our interns are going to be, is taking those Excel spreadsheets, taking those photos and cleaning them up so that they can be fed into our learning models and improve them.
Yeah, about 10 years ago, I wrote another Manning book called TICA in Action, and TICA is basically a forensic content detection toolkit that's really all about data preparation. It does 2 or 3 things right, which actually, if you think about it, I mean, tensors are the same way, right? If you're doing more than 2 or 3 things, you're doing too much, right? So you only can do 2 or 3 things at a time. So TICA basically takes a file in, guesses its file format, spits it out, one of the thousands of them, and then it extracts the text. If it's got a parser, which most 100% of the time, 99% of the time it does, gets the text, the metadata, the language information out. It was a statistical toolkit that was built to do that. Today, largely, with all of these algorithms that are sort of biologically inspired, these neural networks and so forth, all of the process of TICA, if you think about what it was doing, feature extraction, feature generation, preparing features in a standard way, it's really been eclipsed, by deep learning and by these networks and by tensors. And over the last 2 or 3 years, many people have asked, me and the TICA community and things like that, how are these going to kind of, impute, get in, start to learn and provide this knowledge to the community? And that's actually how I got involved really deeply in the image captioning and stuff with TensorFlow and building the show and tell model years ago. Was we were basically trying to add those capabilities, start to add capabilities like TensorFlow and tensors to TICA. And so, yeah, anyways, in the book that I'm writing right now, Machine Learning with TensorFlow, 2nd edition, that Scott's going to pen the foreword to, I got him on camera saying that now.
Yeah, exactly. When's that due? When's that due, Chris? Due soon.
You got a couple weeks. You're fine. But,
good.
We're going to cover that, and we're covering it. A lot of the work in the book is data preparation. Is that 80% and 20% complaining about it? Because, we're not going to do the work. There are going to be people that invent new network architectures. I mean, neural architecture search and things like that is happening all the time. And that needle is being moved. But a large majority of the people are going to apply neural network architectures, to these problems. And we spend a lot of time doing it. And we're spending a lot of time in Scott and I's blog series talking about it as well.
It is a very cool topic. Before we wrap up here, I want to just take a step back to kind of one of the leading topics of the piece was around analyzing all that COVID-19 data. But as we're hopefully, we see some countries getting out of the quarantine mode, and here in the States we're still working on it. But what do you guys see as the impact of the COVID-19 pandemic? How do you see that impacting the machine learning, artificial intelligence field? Are we going to see folks want to step up and apply in different directions, or is there going to be a little bit of a day of reckoning coming here where folks are going to say, you know what, you missed this one, fellas?
I'll add a couple of comments here. I think what we're seeing, anytime you introduce a new technology, there's a lot of things called change management, which is, people have to, test these things out for themselves, see how it might impact their jobs. And that's usually the long pole in the tent for any new technology, all the way back to electricity and whatnot. But look at what's happening now. We're all working remotely. We're all using video, and we're seeing a lot of businesses start to say, "Can I do remote sensing?" And now we have computing for the first time can start to do that. I mean, we're like, look what we're doing here, and because of so many people now being immersed in it, because of we're stay at home, a lot of the change management issues are being addressed immediately. And so people are now starting to see, I can actually do the video. I can manage people remotely. I can sense remotely. This AI is pretty neat. And so we're getting, inundated with having to figure this out. And I think what that's going to do, if anything else, is going to accelerate what people call digital transformations, where people are saying, oh, I'm now used to this. I want to start pulling in these tools because it's going to help me balance my work-life balance. And I think, COVID's really helping us with the change management issue of introducing these powerful technologies of video and language and AI into business and our daily lives. And that is a very positive outcome, I think, that's going to help a lot of economies, through the recovery here. I don't know if there's any thoughts you may have.
Yeah, no, I mean, the thing to add to that is that during COVID too, I hear this from a lot of people, colleagues, peers, others, is we're supposed to be available instantaneously. there's a lot of studies that are going on right now where, if you were on campus, at a place, in between meetings, there were these magic things called gaps, where you used to be able to walk from one building to another that are sort of gone, and people are very focused, and, people's attention, on things has sort of shifted in kind of dramatic ways. Given that attention, and there's no better time to have these types of techniques, again, just to take those few moments that you might have, or that you force, into your schedule, to kind of prioritize what you're looking at, or to have those types of signals come back, or like Scott said, to reply to a meeting invite for you, or, help suggest an email reply. I'll take them. And so will most everybody I know, during this time, to allow us to sort of be more efficient and to make use of the time so we can have some balance.
Exactly, Chris. I think the demand for this is going to skyrocket, because help me with my time so you can answer the common questions, and I'll spend my time on even more valuable input.
Oh, it's the, you know what? I want to get my job done so I can spend time with my kids, take them to the soccer game, take them to whatever it is that might be going on. Right? I can go out and grab a beer, and because I'm done my job, it's the end of the day. Absolutely.
There you go.
Fellas. Yeah. Okay.
Or I can head to the other room and play Fortnite with my kid who's begging me to, and things like that. So
absolutely. Well,
I am on Twitch, right? That's right.
Yes.
Anyways.
That's it. Yeah. Well, thank you so much, guys. This was really informative. I've learned a lot, and I've got a bunch of different places now where I want to go and start applying some of that learning to some of the learning models around some of the deep content that I have, whether it's Twitch chat or pictures of hats that I have, all kinds of stuff. I really want to unleash and see what information I can unlock about that using tools like Bert. Thank you so much.
It's been a pleasure.
Well, thanks, Jeff. If anybody wants to learn more, please follow Chris or I, or we're both on Twitter, and we'd love to engage that way. And I think we're also going to have more hands-on, Jeff, with you if you're interested, and actually show you how you can do this in just a couple lines of code. And that's sort of our next post that's coming out soon too.
Love it. Oh my gosh. And we could do some live coding together here on the channel.
Oh yeah.
Oh
Bert
my gosh.
Live. That'd be fun. We should do Bert Live.
Yes. Oh, I love the idea. Let's do it. Let's get back together in a couple weeks, and we'll make that happen. Oh,
awesome.
Very cool.
Thanks, Jeff. Hey, Chris, great to see you again.
Great to see you both. It's been a pleasure.
All right, and this has been Manning Publications, How We Model Language as Tensors. We'll see you later.